Hello and welcome to my VFX second year technical effects project. For this project I decided to focus on flip simulations and create a garden cascading rocky water fountain. To start this project, I began by looking at real-life examples of water fountains and found videos online that looked at the motion of the water as it poured down fountains, with similar designs and textures to how I wanted to have mine. During my initial stage of research, I also tried looking for examples of other visual effects water fountain simulations. However, found most were examples of different types of fountains where water is shot out at higher velocities, creating more splashing and foaming than my simulation would have. Due to my fountain cascading, I briefly decided to look at waterfall examples, both real and simulations. Although these provided good information about how water arcs off an edge when it has velocity, because of the scale of the water in a waterfall, most of these examples were not very relevant to my project. After my research, I began to look for assets online, however struggled to find anything that would match my idea. Therefore, I went to Maya to create a low-poly water fountain and then took this into Houdini as a starting point to my main scene project file. I remeshed and repaired my model, then used a mountain node to create the rocky texture that I could use for high-poly baking when texturing. Once I had my asset, I created this low-quality simple test as a proof of concept for my idea. This confirmed my idea was possible and showed me the major parts I need to refine for this simulation to look realistic. From my first test, I could see I needed to start by scaling my fountain and particle separation to create a more detailed fluid motion. However, after scaling, the small tank would not fill and begin to spill over to fill and overflow the lower level tanks in the 8 to 10 second video time. To resolve this, I created flip tanks in each of the lower tanks, so at the start of the simulation, there would already be water in each level. I did this by selecting the faces inside each tank with group nodes and deleting all faces not in the group. I then used the reverse node to flip the faces and used a polyfill to close the tank area. With these, I added a normals node so I could better view each tank geometry and was ready to turn them into flip objects. Taking each tank into a separate geonode, I used the configure flip tank to convert the geometry into flip tanks. Initially, I had issues with my base flip tank intersecting with the fountain model, causing water to spill out the base of the simulation. So found, by turning on the implicit bounds under domain of the flip tank, it made the tank much more accurate to the original mesh. I also created 2 other emitters in the top and middle tank to further increase the water being made to ensure all tanks would fill and spill out into the tank below. All my emitters were made with simple geometry and a points from volume node, which determined the particle separation for all flip objects in the simulation. It is important for all flip objects to have the same particle separation in order for them to interact. So I copied the particles from volume parameter and pasted it into the particle separation for all my other flip tanks. Now I had my flip objects, I merged them all together in a geonode, so when imported into my DOP network, they would all interact with each other. For my simulation, I used a static solver and static object to create my collision surface and had to greatly turn up the uniform divisions to cover the whole mesh due to its unusual shape. I then imported my flip objects and input my emitters into the volume source node. When starting the sim with these, I found I had set my particle separation far too low, causing the program to crash when it ran out of memory. So following this, I reduced my separation to a value of 0.015. I found this was much better to simulate at this stage. However, found later on, I was once again limited by the computer's RAM, being unable to fully simulate 8 seconds of video before the program stopped. It was clear I had too many particles in my simulation for the memory of the computer, but increasing the particle separation any further drastically reduced the detail of my fluid, making it look a lot thicker than water, creating a more viscous fluid. Therefore, to reduce the amount of particles without changing this separation, I decreased the depth of each tank by going back into Maya and changing my original asset model. Once the tanks had been shrunk and there was considerably less particles, I was able to run a full simulation. To better replicate my research, I needed to get the water to cling to the surface as it spilled. This video best shows this happen as the water reaches the edge. Some of the water flies off, but some sticks to the rock with surface tension and gently rolls down the vertical side before eventually falling to gravity. I created this effect with the gas stick-on collision node. This allows me to control the force applied to the water as it rolls off the edge, so that any particles a certain distance from the model are pulled back onto the surface. I used a much simpler simulation to dial in the settings of this node before copying it to my main scene simulation. This meant I could mess around with the settings in a lot faster sim to cut down on time. Finally, I meshed the flip particles with a DOP import and particle fluid surface node, in which I could tweak the mesh to better replicate the scale of the water if it was real. When rendering, I used two simple lights instead of a HDRI to cut down on render time. I originally rendered with Solaris and a second fluid mesh that created a smoke-like volume opacity in the water. However, this second fluid mesh made it very noisy, and Solaris had multiple issues rendering fluids. Therefore, I chose to render in Mantra with a much simpler material usage. In review of my work, I am unsure if I was limited by the computer's memory capabilities or by the way I set up my simulation, either way causing a sacrifice in fluid detail to ensure the project got finished. I also would have liked to add more to the simulation, like foam or bubbles where the water interacts, to create a more realistic final outcome. However, I am happy with my problem-solving skills and ability to research and plan out a project to full conclusion. Thank you for listening.